So if you click on this video, that means that you have a mirrorless camera or just a digital camera that you want to create a larger battery for. So you need some very basic stuff. You need a buck converter, B-U-C-K, or a DC to DC converter, or a step-down converter that will be able to take in any voltage you give it and bring it down. You also will need a dummy battery. These are usually very easy to get. You can just buy them straight off of Amazon. Now that will come with a dummy battery and a power supply that will connect straight to the dummy battery. And the last thing you will need is a battery itself. You can pull them from pretty much anywhere. You can even use a car battery, which I could show that, but it's not really a car battery and they're very heavy and I don't want to drop one like I just did. So all you need to do is take your battery. Once it's done, plug it into the input. Make sure it's the input side of your buck converter. Connect it, and then from there, connect that to the dummy battery, and that's it. You set the voltage. Now you can either buy a fixed voltage at 9 volts or whatever voltage you need, or you can set it using the golden knobs that usually will be on, come on, focus. Focus. The golden knobs that will be on your battery. And that's it. That's literally all you need to do. Battery to buck converter to dummy battery. That's it. It's very simple. And now we're going to go into a little bit more depth and then the actual explanation of how these batteries work, just so you can learn something. So, this is a 10S 1P cell, or 1P battery. Pretty much means there's 10 cells in the battery in total. Now that means it has a 36 volt cell, or 36 volt in total, which we will get into later. So this is a buck converter. This buck converter, it is a special buck converter. Actually, I'm gonna unplug it right now real quick, just so I don't accidentally short anything and catch fire, because with batteries, the last thing you want is to short them, because since they have a stored voltage, that means they are willing to output them as much as they want. So if you look here, this is actually a pretty nice buck converter. It has an on and off switch right there, which is called a soft on and off switch, because it's not really disconnecting anything, it's just going right through it. And as you can see, there's some stored battery left, or stored charge left, and that's because of these capacitors, these round things on the top. And so those two knobs right there are potentiometers. One of them controls the voltage, one of them controls the current. Now, the cool thing with power supplies is that when it comes to current, it's not a matter of how much the thing can supply, it's a matter of how much the circuit is asking for. That's what you care about. So in other words, you can use a 30 amp power supply on a circuit that only asks for 5 amps, but it does not go the other way around. So, and that's for most modern day circuits, because most modern day circuits are only going to ask for a certain amount. Older circuits might say, okay, you need to use a specific charger, because if you can give me 12 amps, I'm gonna take that 12 amps, even though I only need 5, and that can lead to devices heating up, exploding, melting, or just ruining your day overall. So, yeah. So this is a fixed current limit. So in other words, you're not setting the output of current, you're setting how much current can be given by this buck converter, or by this adapter. And the voltage actually just controls the voltage. How much it puts out, it's just putting out current. If this ends up taking in current from the output terminals, that means that something has gone horribly wrong, and you just gotta pray that nothing goes wrong. So, yeah. So that's the buck converter. They're very easy to buy. You can literally just look them up on Amazon, AliExpress, Adafruit, and just know what you need. Usually they're gonna say it's a operating range from however many volts. That is, I think, a 6 to 40 volt, and it can output from 0 to 20 volts. Actually no, that can do 30 volts because it's 60 amp. It can do a lot, but as long as you get something within your operating range, you'll be fine. Now, actually, we're gonna now get into the battery. This is a BMS. This is not the same BMS that is on that battery. Why? Because I don't want to take off the duct tape. But this is actually the same exact type of BMS that's inside of there. This is a 10S BMS, which means, as I said before, it works for 10 cells and however many pairs there are in each of those cells. So, they work by having the positive and negative end of each pair of cells, be how many cells there are in there, connected to the board, and what it does is it measures the voltages of each individual pair of cells to make sure that none of them goes too much out of whack, which if it does, ideally if you have a good BMS, it shouldn't be a huge problem because the voltage will just shut up, the BMS will just stop outputting. But if you don't have a good BMS, you could drain a cell so low that it won't come back, which that's the main problem with cells. If you drain more than I think 3.2 volts out of the cell, so in other words, if the voltage in the cell drops below 3.2 volts, these can't be recharged, and you've effectively killed the cell. That's not something you really want to do. Trust me, it's not very fun. So these pretty much stop that from happening. They also stop you from overcharging the battery. Let's say I plugged a 50 volt charger into this thing. It would not work because it would short the cells and explode the cells. If I plugged in a 36 volt adapter, which I got one in the back over there. If I plugged in a 36 volt adapter, it would only charge the thing up to 36 volts. So, where was I going with this? So pretty much these control the actual charging of the cells. They make sure that they go from the operating range, which is usually 3.6 volts to 4.25 volts. 4.2, anything higher than 4.25 is really risking it, but 4.25 is safe. Usually most non-smart or non-digital well, everything's digital technically. Non-smart BMSs will go to about 4.2 volts just for safety. But yeah, it pretty much just regulates the voltage of each of the cells to make sure nothing goes out of whack. Now, you can bypass the cells, but that's a whole different thing. I don't want to promote that. I don't want to say that if you are not confident with batteries. I am fairly confident with batteries. I built many multi-cell batteries. For example, the battery that I built for my bike, it can do well over 30 miles. It uses well, it's a 14S 4P, which means there's 14 cells, or 14 cell packs, and there's 4 cells in each of those cell packs. It's a pretty beefy, it's a really good battery. It's a pretty beefy capacity, really good battery. So yeah, that I guess explains the battery. Controls the voltage, controls the output, make sure that none of the cells go bad. Now, you just go to the dummy battery, which I guess is the simplest. It's literally just a battery, you put in a DC voltage and that's it. You just have to make sure that the voltage that's being output from the buck converter is the voltage that is being output by your adapter. Now, you can do that a multitude of ways. You can do that using a multimeter, which measures voltage. If you don't have a multimeter, well, you should get one. They're cheap. You can buy one for like $5. They're very useful for pretty much anything that has to do with electricity. There's a lot of science behind it, but you can measure a lot of stuff, and it's usually exceptionally helpful to make sure that you didn't just kill something. But if you can't measure something that way, literally all you need to do is just look at the back. Most power supplies, keyword most, will have the actual output on there. So if you look, it says 8.4 volt output, which means 8.4 volts. That's it. You just need to set your buck converter to 8.4 volts. Now, sometimes it might not be actually 8.4 volts. I know for a fact that that power supply actually does 9 volts power output. So, yeah, sometimes you just measure it, or you just tweak it. Don't go too high in your buck converter. You don't want to go too high. One thing you could theoretically do, if you don't have a multimeter, is buy a fixed buck converter. A fixed buck converter, if you're not experienced, makes your life so much easier because you don't have to worry if you're going to output that voltage. You just know that you will be outputting that voltage. So, this is a fixed buck converter. Let's see. So as you can see there, it can take in 8 to 40 volts DC. Also, buck converters, all this stuff is DC. Don't use AC voltage. DC, by the way, is direct current. AC is alternating current. Oh, I hope I'm right about that one. But this will take in 8 to 40 volts, and it will output 5 volts. And it can do a max current of 5 amps discharge. Now granted, this will probably get very warm, because it's passively cooled, which means there's no fans. But yeah, so you could buy a 9-volt buck converter, and so instead of outputting 5 volts, this would output 9 volts. Wouldn't have to worry a bit. Wouldn't even have to set the voltage or do any twisting or turning of the knobs. I would literally just need to plug in a battery to the input, plug the output into the dummy battery, and that's it. It would really just be that simple. It's not very hard to build a battery. The only thing is, though, you have to make sure that the battery is safe, it's not old, and it's not sketchy. You have to have the correct stuff that converts the cells. I wouldn't use just some random buck converter that I found on the side of the road. It would have to be something that I bought and that I'm confident in using. And usually you could just do some basic tests with it. You never want to just plug it right into your camera. I've used this buck converter for massive fans that I've found, for a computer project that I was working on. It's pretty cool. And yeah. And then the dummy battery, again, just buy one off of eBay or Amazon. Preferably new, because you gotta remember, if you're plugging this into your camera, that means that you are trusting over, like sometimes over thousands of dollars on just this. And if you mess that up, yeah, it's not be painful, or not be fun. So, I mean, that's really it. I mean, in just a quick recap, you need a battery, which plugs into a buck converter. From the buck converter, that goes into your dummy battery, and then, well, the dummy battery goes into your camera. And that's it. That's all you need. You can now build your own battery. You can buy your own battery. Honestly, you can actually buy lithium-ion cells, or lithium-ion batteries, straight off the internet, with everything already done. So you literally just have to plug it in, and it'll even come with a charger. That is what I would personally suggest. I have built my own batteries because I'm experienced, and, well, I know for a fact that I've been shocked multiple times and burnt multiple times. I know that I can handle it, hopefully. So, yeah. So, if you like what you've seen, or if you have any more questions, just ask. I will gladly respond in the comments below. And, yeah, that's really it. Well, see ya.